Compare the monthly payments and total loan costs for the following pairs of loan options. Assume that both loans are fixed rate and have the same closing costs. You need a $190,000 loan. Option 1, a 30-year loan at an APR of 7%. Option 2, a 15-year loan at an APR of 6.5%. We want to find a monthly payment for each option. In order to do this, we need a formula. And this is our formula. PMT is equal to P times the quantity APR divided by N all over 1 minus the quantity 1 plus APR divided by N all over negative NY. What do all of those mean? Well, what we have here is PMT is going to be the payment required to repay the loan. P is the loan amount. APR is going to be the interest rate as a decimal. N is the number of payments per year, and Y is the number of years in the life of the loan. So we need to get some information from this. We need to figure out what PMT, P, APR, N, and Y are. Obviously, we're looking for PMT, so we need the other four. And I'm going to use this down here. I rewrote the formula so that I can have that as a visual as I scroll through. And so we're going to look at the fact that the monthly payments, or N, is equal to 12. Since there are 12 months in a year, our monthly payments are going to mean that N is equal to 12. We're also looking at the fact that P is going to be $190,000. Option 1 has a 30-year loan with an APR of 0.07. That's 7% as a decimal. Then we're going to be looking at option 2, which is a 15-year loan with an APR of 6.5% or 0.065 as a decimal. So remember what I said, N is equal to 12. We know that P is going to be equal to 190,000. Option 1 yields an APR that's equal to 0.07 and Y is equal to 30. Option number 2 yields an APR that's 0.065 and a Y that is 15. So for option number 1, we're going to type all of these numbers into our calculator. So we've gone ahead and put 190,000 in place of P, 0.07 in place of APR, 12 in place of N. In the denominator, once again, 0.07 in place of APR, 12 right here in place of N, 12 here in place of N, and then 30 in place of Y. And then we're going to put that into the calculator and we're going to come up with our answer. Now let's go ahead and type this, and I'm going to type it exactly how I wrote it. I open parentheses, and I'm using the keyboard for this, but you can also type it by using your mouse. But 190,000 times, which is the asterisk key, I'm going to open parentheses again because that's what I have around the numerator's 0.07 divided by 12. I will close parentheses, and then I will close parentheses again. You have to make sure that if you open a set of parentheses that you have a matching closed parenthesis on the other side. So that's my 2 interior, and these are my 2 exterior. Okay. Now I'm going to divide, and once again I'm going to open up parentheses, as you can see right here. Okay. So once we open those parentheses, we begin to type, and we have 1 minus, we come to another set of parentheses right here, so we're going to go ahead and open that up. And then we're going to have on the inside of this set of parentheses 1 plus, open parentheses again so I can do the division, 0.07 divided by 12. I'm going to close those parentheses, and then I'm going to close again, because if you'll notice there's a set of parentheses right here where my mouse is bouncing up and down, and right here. That's the outer set, and now it's the inner set right here. But I want to make sure that this exponent right here, the negative 12 times 30, gets applied to this whole expression, 1 plus 0.07 to the 12th power. I'm not to the 12, divided by 12. And so now I'm going to go ahead and make sure that these close. Okay, yes. And now this one closes with this one. And so we'll go ahead and do our Shift 6 key, or we can simply type this X to the Y key. I'm going to open a set of parentheses. I'm going to type in negative 12, and we're going to times that by 30, and we will close those parentheses. Now remember, these parentheses are closed, this parenthesis here and here are closed, this parenthesis here with this one are closed, and that leaves this lone parenthesis, so we will type in an external parenthesis, and you'll notice that right here I'm about to highlight it in a box. Well, I thought I was going to. There we go. That matches exactly what I have written here. So then we'll go ahead and we'll left click equals, and we end up with this number right here that I've just highlighted in blue, $1,264.07. Since the problem told me to round to the nearest whole number, I'll go ahead and state that PMT for this particular part of the problem is going to be equal to $1,264. Okay, now we're going to go with option number 2. Okay, so option number 2. Once again, I'm going to go ahead and write everything down so that I've got it all spread out. I have payment is equal to $190,000, but notice that the APR is now 0.065 and N is now 12. Or I mean, it's still 12. I meant Y is now 15. So let's go ahead and bring the calculator in, and we will go ahead and we will type that in exactly as it's written and hopefully get the correct answer. So open parentheses, 190,000 times open parentheses 0.065 divided by 12, close parentheses twice. I'm going to divide. I open parentheses 1 minus open parentheses 1 plus open parentheses again 0.065 divided by 12, close parentheses again. Then we're going to do the shift 6. We're going to type in a negative symbol times 12 in front of 12 times, and we go with 15. Okay, and then for this one, I should have closed that in parentheses also, but then I will go right now and do that, and that's what I have. And then I'm going to have to close the parentheses on the outside. Let's just make sure I got this correct. Okay, I got a parenthesis here, and its mate is right there. I've got a parenthesis here, and its mate is right there. I've got a parenthesis here, and its mate is right there. I have a parenthesis all the way out here, and its mate is right there. So I go ahead and left click equals, and I get 1655.103. Once again, we're going for whole numbers for this, so I round that to 1655. So the next thing is I just go ahead and go into my MATLAB, and I'm going to enter 1264 for option 1, and I'm going to enter 1655 for option 2. And remember, as I said, we're going to round to the nearest whole dollar. Now, the total amount paid for option 1, we're going to do that by taking 1264, which is the payment amount, multiplying by 12, which is the number of payments in a year, multiply by 30 because the term of the note is 30 years, and I get $455,040. Next, we'll go ahead and multiply 1655, the payment for option 2, times 12 times 15, because there's 12 months in a year and we're looking at 15 years, and the total amount paid is going to be $297,900. And you'll see that there's quite a difference. But the next part of the question says, compare the two options, which appears to be the better option? Well, if you can afford the monthly payments of $1655, the second option would definitely be the preferred option, because you would pay off in 15 years and you're going to pay almost $200,000 less in interest. So, but that's not always the case. So, option 2 is a better option, but only if the borrower can afford the higher monthly payments over the entire term of the loan. So, we'll go ahead and we'll mark this as being one of the answers. Oops. Okay, and so there we go.